So Mark's going to write, you guys are going to help him figure out
line.
what's the
Yeah,
set
it's
of
just a
things that are
line
equidistant between 0, 0, 4 and the XY plane.
Z. Right.
I'm going to sit in this chair. You guys going to help him or what?
So starting with the plane and the point.
I can't draw, by the way. Oh, sorry. I can't hear you. That's wrong.
So the shortest distance is a line, and then if you increase the distance,
This distance, right?
yeah. And don't those trace circles on the plane?
Yeah. And actually, if it was really super duper close, it would be
Just the point.
a point, and then it'd be a little bigger circle, and then a little bigger, so it'd be a paraboloid, right?
Paraboloid, I think it would just be a circle.
Just a circle.
Yeah,
Oh, like a hemisphere?
I think.
Or like a cone?
Well, like when you
like a hemisphere.
like when you're dealing with a compass. Is it a compass or a protractor that I'm thinking of?
A protractor.
Protractor. If you increase like the distance, it traces one circle.
That's a
And you
compass.
increase
Yeah, that's a compass.
Don't listen to Travis.
and then you increase the distance again, it gets a little bit bigger of a circle. It's kind of what we're doing here.
But would we include these actual lines? Because
I think the set is just the circle traced.
Maybe you'd have levels of just circles, because each circle would be equidistant from that point. So then you'd have level curves of
Oh,
circles.
you moved.
coming out, right?
More like a globe.
So maybe
that's
like
probably a good thought that the level curves have to be circles. But you know a bunch of things that have level curves that are circles, right?
I wonder if that's a cone.
yeah, because like say you have like this set of things equidistant between these, like this is what's between, this is what's between. It's a line. And
Wait,
if you
are
went
the
out
things on the
to
plane?
infinity,
I'm confused. Are we looking for a shape, or are we looking for
like you just keep getting flatter and flatter, and it would
set
be
of
like a really flat cone.
Yeah.
points?
So
It'd be like having the tip of a cone at
0, 0, 4,
0.004.
and then going out with circles getting
Mhm.
bigger and bigger.
But what would this final angle be?
It'd be whatever. It'd be.
Depend on the distance between.
Yeah.
But are we looking for the set of things that are equidistant from
It'd
the
be
point
whatever hits
on the
XY
plane, or equidistant between the point and the
Be
plane?
whatever hits it.
So you're looking for the set of things that are the same distance from 0, 0, 4 as they are from the XY plane.
Okay.
So I think you need to come up with two formulas for distance and set them equal to each other.
Yeah, we're gonna get some sort of bowl.
And we definitely know that the cross section, the horizontal cross sections are circles, right? But that could be a cone, it could be a circular paraboloid, it could be a half a sphere, it could be really any kind of shape spun around.
Shouldn't
Do you guys remember?
it be a complete sphere? And it's just a sphere in between the 004 and
For all the
Yeah,
points
twice
on a sphere the same.
So
So the thing's equidistant between.
equidistant from both points, the XY
yeah,
plane.
and then if we go out in one
004, right?
direction.
Here and here, it would be. this
No,
point
not
right
all
in the middle
points.
there.
well,
It's a circle.
the shortest distance between
Oh,
that
you're
point
right,
and the
right,
plane
right,
is just
right.
a straight line, so it'd have to be up more.
Yeah, a circle. No, not a sphere, but a circle. A circle in between 004 and the XY plane.
Yeah, it's
See.
Well,
No, because it'd be closer to the XY plane than it would be 004.
squirrel.
Mm.
Oh,
squirrels.
Yeah,
true.
I do like squirrels. They're super majestic.
My dad has a bad one.
How about this?
No, not chatterbox.
Can you write down a formula for how far an arbitrary point is from 0, 0, 4?
do like a
Isn't it the
slice
square
where
root of
x is
x
0
squared
and then a
plus
slice
y
where y
squared
is
plus z
0.
squared?
Close.
Use distance. Or minus z squared.
So,
Good start.
yeah, it's just x squared plus y squared plus
Oh,
z
that's
minus
right.
4
You have to use
squared.
the x and
And that would
And
form
that's
what kind of
what's
shape?
the point?
It forms
So
like
So that doesn't form anything, right? That's just a
it
number.
doesn't.
That's just
Oh,
For a
well, if you
specified
have-
x, y, and z, right? That thing's a number. But what do you want that to be? You want that to be the same, right?
the distance from this point to the plane.
Okay, so how far is your arbitrary point x, y, z from the plane?
it'll just be z from the plane.
Well, the plane would be what?
Well, if you have the xy
z
plane, then
equals 0.
whatever
which is
z
the
is,
plane.
it's its distance from the plane.
What?
For the xy plane,
Mhm.
any point wherever you put it, its distance from the plane is just going to be its z component.
Okay, yeah.
So
Yeah.
that equals z.
Yeah.
Like I have another marker.
Toss 'em up.
Mark.
Good.
Trade off. So the left side's the distance
That's a cone.
between any
That would
two
be-
arbitrary points.
I'm not sure if that makes sense. Z equals the square root of x squared plus y squared plus z squared.
The left side is the distance equation between any two arbitrary points.
The distance between.
Okay.
But on the right, you probably shouldn't have z. You should have a constant. By the way.
The equidistant.
Use a point x, y,
The distance is 2.
Yeah, 002
Would be
would
equidistant.
satisfy that equation. Because you have negative 2 squared square roots, which is positive 2 equals 2.
But that was good. That did you guys all notice what Donald just sort of spat out there?
Yeah.
That 002 satisfies this? Why is that important?
Because it's squared.
Yeah, because it's pretty clearly on the surface that you're talking about,
Yeah.
right?
So at least we know.
So it better satisfy this.
Yeah.
It's at least 1 point.
Okay. Is that a recognizable object?
I think we'd have to multiply it out and do some stuff to it.
Because that's just a circle. You square the constant on the right, and you get.
Well, it's because we have z on both sides, so we don't have like one output.
Yeah, we only get to.
Mm-hmm.
I mean,
So-
we could square it and then move the z over and then
Yeah.
square root that. That would just assume we could. We would have something on the top and something on the bottom under the xy axis too. And that would be a plus or minus.
Yeah, we might get a.
Wasn't there a shape?
I would advise that you
Maybe
stop
two shapes.
thinking and start writing down what you said earlier.
So just multiply it out, try to get z by itself.
Yeah, multiply it.
The z's are gonna, the
Yeah,
z
the
squareds
z
are gonna
squareds
cancel,
are
which is
cancel.
nice. So it's minus
And then
z
that'll be just
squared.
c later.
Oh, yeah, so yeah, we'll just have a. So it'll be minus 8 plus
Minus 16.
Actually, this would be positive on the other side.
Yeah. That's a recognizable shape.
It's probably.
Nice.
Shifted up
So
to.
this, so
So where did the plus or minus you were worried about go?
it died.
It died.
But why isn't it there at all? Like, you were worried about plus or minus, right?
Because we have a z squared on either side. That would cancel itself.
I would maybe say you didn't have to take the square root of anything,
Yeah.
right? So there was no worried about it, no worrying about a plus or minus.
So is this? I think it was like pre-calc 1. We talked about. You have a line. I can't remember what it's called. And a point. A parabola is the set of points
Mm-hmm.
equidistant from. This equals this, and this equals it. Well, that's really long, but. Is this just kind of rotated 3D?
Yeah, of course.
Oh.
Add another dimension. You
Right,
spin
because
it.
if you slice through the picture that you started with, right, you're going to end up with a line and a point. So of course it should be a parabola in all the cross sections that are vertical. And you guys already figured out that all the horizontal cross sections were going to be circles.
And this is the same definition, but in 3D.
Yeah, and my only quibble about your picture here is that your distance from the point to the parabola should be slanted, but your distance from the parabola to the plane should be vertical.
From the point to.
So it should be slanted to the parabola, but then the other half should be vertically.
go Sean.
Yeah. I mean, oh, I gotcha.
Shortest distance
Yeah,
between a
yeah,
point and a plane is a line perpendicular to the plane.
Yeah. Cool. Good work, guys. What was the moral of this? Like, I kind of put you into this, but I had a moral that I was trying to teach you.
Write stuff down and start talking about it.
Yeah, like instead of sweating it, sometimes you just start writing something, and even if it's wrong, it'll help you get to the right thing. You guys see that?
Yeah.
Like, we were kind of paralyzed with concern between here and here about this, like, plus or minus thing. It didn't even matter, right? Like, we could worry about that plus or minus all day, but if we just try to do something, even if it's wrong, it'll inform our approach.
The only thing I'm confused about is why there's a z on the other.
Oh, why
side.
this distance, or why this is z?
Yeah.
So, what I would say is that this thing you were looking at here, you were thinking distance from point to 004.
Right.
And then this thing, what you're thinking should be distance from point, right, XYZ, to XY plane.
Right.
Is that constant? Like, are all points the same distance?
No.
No, so there's got to be some variable.
Okay.
And that variable is the height, of course, right?
Okay.
If I'm wondering how far it is from the horizontal plane,
Right.
well,
Which is why those lines should have been vertical after the.
exactly.
Okay.
Yeah, so in the two-dimensional picture, right, this would be a 2D distance formula that I'd be running. And this thing would just be the y coordinate, right?
Right.
It's just how high it is. Cool. Questions, thing? Cool. Good on you.